Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little Q&A button there. Type in your question, hit submit, and I'll get to those at the end of the session. If you're joining live on YouTube, just make sure to use the live chat function wherever it happens to be on your system that you're using. It's usually top, bottom, left, right. I'm not really sure where it would be. But wherever it is, you can use the live chat, ask your questions there, comments, what have you. And then, let's proceed. So if you have those, we will get to those at the end of the session. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic. Then before I did that, it was 8 years at Subaru. So worked at a dealership, and over time, I guess, just became that diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So enough about me. Let's talk about driver comfort systems. So driver comfort systems decided to make this session kind of a catch-all with these different systems that are nice to have on a car, but they're not really necessary, right? They don't make the engine run. They don't make the transmission shift. They don't really drive the car down the road. They're things that make the driver and the passengers more comfortable. And that, in my mind, these are the things that are like really, really kind of out there and not necessary. Some of these things we're going to talk about, it's like, why does that even exist? But hey, they do. And we need to know why they work and how they work and how we can test them and how we can go through scanner functions and so on. So first, we're going to cover heated and vented seats. So that's a really nice to have in my mind, especially if you live in a cold climate like I do. So having the heated seats, vented seats for the summer. It was pretty hot this summer. Heated steering wheel, also nice to have. Noise canceling systems. So that means I don't want to hear what's going on outside. I don't want to hear road noise. I don't want to hear my engine. So they're going to cancel the noise out with that. The other side of that coin is we have sound generation systems. Certain types of vehicles are very quiet, hybrids and electric vehicles. So we need something to allow pedestrians to be aware that this vehicle is coming down the road. So we have sound generation systems on it. And also we have electric motor mounts or electronic motor mounts on some vehicles nowadays as well. And that can have, they lend themselves to their own problems. Plus there are, if you're trying to diagnose certain drivability issues or rough running engine, that might tend to mask it. So we also need to be able to deal with those. So first off, let's talk heated seats. So what it does is we have the fabric, of course, on the outside, and underneath the fabric, we have an electric heater element. So it's a bit of a wire, and it's high resistance, so it generates heating, kind of like a toaster oven element, but not quite as hot. We're not trying to burn you. We're just trying to warm it up a bit, maybe 90, 100 degrees. Usually the seat and the back part are separate. So the bottom part and the back part are two separate pads. Sometimes they'll come as one unit and go all together. Otherwise, they'll just kind of connect together. It can be found in the front seats and now also in the rear seats. Some vehicles, they'll have all the front and rear seats will have at least heaters. Some of them will have ventilated too, which we'll talk about here in a second. But it does, if any of these wires gets a short, gets an open type situation, it's not going to work. Maybe it only works in a certain part of it, like over here, and then this part goes out or something like that. How do I diagnose it when I do have a problem? Well, you can kind of feel it, but a really good plan would be to use thermal imaging. So if you have a thermal imager, you can check and see, well, here's the seat. And you can see there, you can't see the elements there. It's just kind of the seats there. On this side, you can see the element there. And then on this frame over here is the good one. And you can see the element going back and forth after they've already fixed the vehicle. You can see just the little hot spots in the element there versus just kind of a unitized heat signature on the seat. So you can't actually see it working. So if it's broken, you're not going to be working. If it is working, you'll be able to see the other side of that coin. And sometimes, and most often in the same seat, is going to have ventilated seats as well. So it uses a fan inside the seat to push or pull air through the perforations in the fabric. So it's either just oftentimes it's like a leather with a perforated leather, so it'll come through. Push or pull the air, just depends on what the manufacturer decided that they wanted to have, because they're really researching this. The engineers talk about there's really no effective way to chill the air going into the seats without making it not soft. So you kind of need a harder element in there in order to chill the air. So instead, they just kind of blow the air, removes the moisture from your body, and allows it to cool off. So depending on the temperature, depending on the humidity, it might not work as well as others, but it is there. So in this case, we have it's a pretty fancy seat here. We got the heater element pad right there and the white and the black stripes there. And then we have the fan, which is blowing through these perforations there. Actually blows through the seat. Looks like in this case, it could blow hot or cold air. So allows it with the heating. You can blow it through the heater element and blow warm air at the driver as well. Looks like it's got electric lumbar adjustment as well. So you can see we have this rope here, and it kind of turns around this and that, and that's how it adjusts the lumbar down here. So this is a super fancy seat. It's got all sorts of things. Heated steering wheel works on the same premise as the heated seats. So we have a heated element in there, resistance wire, so to say. And that allows the steering wheel to heat up and keeps it nice and toasty for you. I had a Chrysler Pacifica rental last week, and it had heated and cooled seats and heated steering wheel and all that fancy stuff. So it's nice to have once it starts getting cool off, like it is around this time of year in certain parts of the world. It is starting to cool off a little bit. We're getting into fall up in the northern hemisphere. So it's starting to have some chilly mornings, 30, 40 degrees. I might want a little toasty steering wheel. Same thing though. If I want to diagnose it, you can say, well, it's not heating up. Well, is it kind of, sort of heating up? Hard to say. But we can definitely tell with the thermal imager. We can see whether or not it is working right there. It's got to be the seam in the steering wheel right there. So it doesn't quite make it all the way around, but that's where the contact is. 112 degrees at the warmest. That's nice and toasty on your hand there. So definitely utilize that. Next one is the noise cancellation system. So what this does is it uses in-cabin microphone and the audio system on the vehicle. It measures the ambient noise inside the vehicle, road noise, engine noise, and the like. And then it has the audio system output the sound out of phase. So if you know anything about sound waves, they're a sine wave. And if you send something out in the opposite direction of that, they cancel each other out. So it plays audio out of phase to cancel out the engine and road noise. Now, it doesn't completely mitigate the noise, but it definitely reduces the noise considerably. So in this case, we have a noise source here. This is the interior. You see how it kind of goes up, down, up, down. The anti-noise is the opposite. It's down, up, down, up. So they cancel each other out. And then we get a result, a canceled out noise pattern, which is considerably quieter than anything around. So if you have noise canceling headphones, for example, that you might use to listen to music on, go for a jog or what have you, works on the same principle. So as an exterior microphone, cancels out, sends directed sound waves out of phase of what the ambient is, and that's what allows to cancel the noise. So some vehicles have that here. Next one, the other side of the coin, is sound generation system. So we talked about on hybrid and electric vehicles, when they're in electric operation mode, you can't really hear them coming down the road. So it plays audio to alert pedestrians of a moving vehicle coming their way. Commonly called acoustic vehicle alerting systems. It was mandated by Japan in 2010, Europe in 2014. US was actually mandated in 2014 as well, but it didn't go into effect until 2019. So they had a 5-year grace period. And it must come on below 18.6 miles an hour, or 30 kilometers an hour. And the reason being it doesn't need to be after that is the tire noise, the road noise of the vehicle just moving would be loud enough at that point at 30 kilometers an hour. You can hear the vehicle moving down the road. Manufacturers will use various tones and sounds with that. So it just kind of depends on the manufacturer what they decide to do. This one we have Nissan Leaf here. Here's the sound that comes out of that. And you should play through the speakers once we get there. So to me, that kind of sounds like a weird jet engine thing going on. They call it vehicle sound for pedestrians. It's VSP. And then in reverse, we have like a little ding. So I don't know why they couldn't just use the same backup alert they use on a commercial vehicles. I don't know. I guess they just decided they wanted to use their own sound, but thought that was kind of interesting. So with that, on that vehicle, underneath the bumper, this is the front bumper beam there, and then we have two brackets with two speakers that look like they fire at each other too, which is kind of interesting, but that's what emits the noise from the front underneath the vehicle. So you can actually hear it when it's approaching, so you don't get hit by a car, which would not be good. So we want to make sure that keeping the pedestrians. And then lastly, before we get live on the tool, we're going to talk about active motor mounts. So they can be either vacuum operated or electronically operated with a coil. They're used to reduce NVH from the engine, so noise, vibration, and harshness. That's the technical term for that. And it just depends on what manufacturer decided to use what part. So in this example, this is on Honda, and they have a vacuum switching valve. So they have a vacuum tank up here, up by the air cleaner, and engine mounting insulator here, and it just varies the amount of vacuum, which will change the amount of stiffness to the engine mount. So depending on how open that valve gets and how much vacuum goes in here, it's either going to be softer or harder, just kind of depending on how. These are electrically operated motor mounts. So what these do is, this is like kind of the newer version on a Honda. So it takes the crank signal, top dead center signal, through the PCM, and then crank out and TDC out. Engine mount control unit, and then the actuator does an opposing stiffness depending on how the engine's run. So if we got a little bit of a vibration there, it's going to move this plunger in and out. It's got a little plunger inside here with a coil, and kind of moves it in and out. It's pulse width modulated. So it just depends on how far it moves is going to change the density of this liquid, or pushing on the liquid anyways. And it's going to allow that rubber to stiffen up, and because we can't really compress the liquid. So the further we press it, the more stiffer it gets. And then the plunger up and down. Now, I've also heard a huge failure point on these is they'll leak. So after a while, the fluid, the liquid will leak out, and then they just won't work at all. So definitely could be a failure point there, or it could be an electrical failure as well. So here's just a closer look at that. And we got the plunger system. We got the magnet around the bottom, so it can push and pull that plunger with an electromagnet. Liquid there, rubber there, and allows it to get stiffer or less stiff, depending on the situation. And then there's just a picture of that, how that would look on the outside. So that's one version of that, with the plunger moving in and out of liquid. Here's another version. This one's on Audi, and what they do, it kind of like a speaker. If you've ever seen inside of a speaker, you have the magnet, and they have a coil around that magnet, and depending on the flux of this coil, it will move up and down inside the magnet. So it'll move up and down. It goes up, it gets tighter, comes down, it gets looser, and we got a membrane on the top. So really, it is a lot like a speaker, just with a fluid chamber instead of having tone on. So it works on a very similar principle with the coil and the electromagnets. A lot of things on a vehicle working with electromagnets. All right, so that's our overview. That part's kind of a little short in this one, just because we're just kind of giving you that high level. Now let's get into the actual on vehicle. What would I be doing with my tool? How would I be going and hooking up to these cars and checking out these systems? So I'm going to go through a few of them here. So first one I want to go through is this 18 Honda Pilot, and we're going to go through the active motor mounts. First thing I want to do is I'm going to go into shop key and see what we can learn about it. Check some wiring diagrams perhaps as well. So I'm going to load through this vehicle. There we go, Honda Pilot loading up. And here's my landing page. So I'm going to go in and I'm going to start searching for active engine mount right there. Oh. And then we have this over here. Got some TSBs on it. So there's one TSB for rear engine mount chirps. Chirps. So the symptom is you hear chirping in the cabin with the engine running, the transmission in drive, and the engine at operating temperature. You do not have a bird trapped in there. It could be the engine mount. An issue with the rear engine mount can cause internal components to wear prematurely. This may cause a chirping once the engine warms up. Do the diagnosis and based on the results, replace the rear engine mount. So here's some part numbers there, warranty claim information. Start the engine and make sure it warms up to operating temperature. And put the transmission in drive and apply the parking brake. Place a stethoscope or a long, thin screwdriver on the airbag mounting bolt and listen for a chirp. So they want you to put it right there and see if you can hear a chirp. I guess it must travel up through the steering column or something. If you hear a chirp from the rear engine mount, go to step 3. If you hear a chirp coming from the high pressure fuel pump, refer to this bulletin. If you hear a chirp coming from the timing belt, refer to this bulletin. If you do not hear a chirp, it doesn't apply. So there's 3 different places we could be hearing a chirp in this case. So we really got to narrow it down, I guess. That's kind of interesting. And then to fix it, we're going to put the vehicle up in the air, remove the engine cover underneath, unplug the connector for the engine mount, lower the vehicle, then listen for the chirp again. If the chirp is gone, repair it. If you still hear the chirp, it's something else. If I don't hear the chirp with unplugging the engine mount, then we're going to listen to support the engine. We're going to change out the engine mount. So it gives instructions on how to do that and torque the bolts properly, connect the connector and install the engine undercover, and you're done. So a failed motor mount on this Honda would give you a chirping sound. Interesting to know. All right, next thing. Let's go down to wiring diagram. Because we do have wires here. So on a 3.5 liter, 6-speed automatic transmission, page 2 of 9. So this is a 9-page wiring diagram. We're on page 2 because the active control engine mount relay is on this page. So that's a good place to start. Go in here, there's the relay there, and then we can see across. If I click on that, we can see it goes across over here. And my active engine mounts are right here. So zoom in on those a bit. See, there's not a lot going on with it. We got an engine mount control module. So it's its own control module. It's got power going in. It's got data lines going in. It's got a ground. And then we see over here, it's just 2 wires. So we got the coil. So pulse width modulated through this coil. And that has the engine mount actuator stiffen up or loosen up depending on what we need. That's kind of interesting. Close on out of that. Come on down to parts and labor. So we want to see how much this is and how long it's going to take. So we have engine and transmission mount. So the front mount, 2.8 hours, rear mount, 1 hour and 1.1 on the side. Transaxle looks pretty easy. And then if we come up here on the active mounts themselves, so those are the pricey ones, $378 and $387. On those are manufacturer's retail price right from Honda in this case. So we have almost $400. Probably can find some aftermarket ones less expensive. I'm not sure, but yeah, that's what they go for, and it takes about a couple 3 hours. So that's my wiring diagram. That's my pricing. Let's go into the scanner and see what we can do. And for this course, pretty much we are focusing just on the scanner functions. A lot of people say, well, you always do it on a Zeus and you talk about kind of component test. And what if I have an Apollo? What if I have a Solus? Great. You got an Apollo or Solus? Just about everything we're going to talk about here is going to apply because this is all scanner side stuff. So I do have to go down here to steering and chassis, active control amount right there. Sim mode. So you see we got codes, we got data, we got freeze frame, we got functional. So on the functional test, we can actually do a reset. We can do a test. We can turn the front solenoid on or off, the rear solenoid on and off, or both front and rear solenoids on and off. So it's trying to diagnose an engine problem. I could turn them off. I can also turn them off, send a command just to turn the one off. Maybe I have that chirp function going on they were talking about in the TSB. I could do that as well. So you can go in there and turn them on and off. Functional test. How about data? What do we get for data? Now this is a simulator, so it's gonna give us just some wild numbers there. But control relay, supply voltages, solenoid currents, so you can see the current in the front and the rear solenoids, and active engine cylinder, and so on and so forth. So this is especially used. It's not only used when we have like a little bit of a motion in the engine. This is most commonly used on these vehicles anyways when it does the cylinder cutout. So if it cuts out down to 3 cylinders, which if we saw the class I did on that, where we can have cylinder cutouts there, it's going to run a little rough at 3 cylinders. So it actually uses those mounts pretty commonly for that as well. All right, so that is engine mounts. Let's go and activate this one. I'm going to talk about the seat. We've got a BMW 5 Series and we got a seat we're going to work on here. So this has got a fancy seat. So we got to come all the way down here to seat control. So we got seat module on the driver's side. Simulator's working tonight. So we got codes, we got data, we got functional tests. So we go to functional tests, we have actuator tests, and we have a whole bunch. Like I said, this is a very fancy seat. So we have backrest angle back and forward, upper section back and forward, head restraints upwards, downwards, backrest width, forward and back seat adjustments, seat angle, up and down, seat depth adjustment, forwards and backwards, height down and up. We can do seat heating intervals, stage 1, stage 3, and stage 2. And then we can reset the control unit itself. So there's a lot of different things we can do just on this super fancy seat. And also data stream. If we wanted to go into data stream, we can look at additional equipment installed, seat adjustments, seat heating, seat adjustment, switch block. How about seat heating if I wanted to diagnose a seat heater on there? So we have temperatures in there, seat heating buttons, what stage it's on, if it's even installed. Seat squab temperature, seat padding temperature. We can see the different temperatures in there. They have actually temperature thermistors in there to read the temperature. So, also speaking of seat heating installation status, we didn't talk about this, but there are some manufacturers that are now providing subscription services for these comfort features. So the vehicles are equipped with them. But if you don't pay your $5 a month for your seat heater or whatever, it won't enable it, so you won't be able to use it. I find that very interesting and possibly a slippery slope going down there. So say, oh, if I want to use my car, I got to make sure my subscription is paid up on this car, right? So it's kind of interesting the way that they're headed with that. So that was the driver's seat. We got passenger seats. We got rear passenger seats, driver's rear seats as well in there. So a lot of different stuff with that. So that is seats. Let's go into the Nissan Leaf with the sound generation function. That's in the scanner as well. So if we come down here, that is under vehicle sound for pedestrians right here under hybrid electric. All right, so we have codes, data, functional tests. If I go into functional tests, there's special functions. There's a sound pressure level change. So if it is not quite loud enough or too loud, choose to change the output sound level of the vehicle sound for pedestrian system. After adjusting the sound level, it will be automatically saved. Select continue to adjust the settings. Continue. And then we can set it at default, which is where it's at. Plus 1 dB, plus 2 dBs, and plus 3 dBs on there. So it actually make it louder. So if it's not loud enough, or you drive in an area where it is loud ambient noise and they're not being able to hear it, you can actually increase the volume if you wish to do so. I know I read plenty of articles with people wishing to disable the system. You can't do it with this tool. You can't do it with the factory tool either, because it is a safety system. You can also test the speaker. So you can go in there, you can turn it on, turn it off. It'll make the sound if it's working properly. So that's good to have. And then as far as data stream, let's see what we get for data stream on this. So your switches, your indicators, your startup sounds, reverse buzzer, whether or not that's on or off, vehicle speed signal, startup sounds, engine speed signal, shifter position. So it needs to know, am I in drive? Am I moving? Am I in reverse? You know, what's going on with the vehicle? So it needs all those different systems or signals. So as long as it's working, you can use that data to validate whether or not it's actually receiving those signals from the vehicle. All right, that is that. Let's go into Grand Cherokee. This has active noise canceling. Active noise canceling system. So I don't want to hear the engine on my Jeep Cherokee. I don't want to hear the road going by on that. So in this case, it's a 918, so we do have security link for this. Just going through that right now. Just unlock the car for me. So on this is part of the AV. As we said, it uses the radio. So it active audio, video, and infotainment, active noise cancellation. Okay, codes, data, functional tests, system tests, and miscellaneous functions. So miscellaneous functions, just going to be your ECU ID. System test, though, will give you a tone test. So it's going to emit a tone, output short test, microphone tone test, and microphone output short test. So you'll be able to test the system by outputting tones and seeing what's going on. Data. You can see we have whether the amplifier is working on mute or not, whether active noise canceling is active, whether or not we have RPM crank signal, driver's window position. If you think about that, you're going to need to know whether or not the driver's and passengers' windows are open, or whether the doors are open, because that'll affect the sound inside the cabin. Hence, it'll affect the noise cancellation of that sound as well. So if my window's open, I'm going to have a lot more noise going on in the cabin that I'll need to try and cancel. And I'm sure there are practical limits to how far this noise canceling can go. I suppose if I'm driving around with all my windows down at 70 miles an hour down the highway, it's probably not going to do much. It might do a little bit, but I don't think it's going to do a whole lot with all that wind coming in. But that could be very well be a customer complaint. Hey, I got a lot of noise in the cabin with the windows closed. And then maybe you notice that it thinks the window's open. I don't know. I suppose there could be a lot of situations like that. That's on a Yeep. Let's go in and this is one of my favorites. This is one of my favorites. So on a Mercedes, found this randomly one day looking through different vehicles. So on some Mercedes, this one is a convertible. It has a system called the air scarf on this vehicle. And that to me sounds like a really silly name, but it literally does what it says. So it is a scarf made of air. So if I'm driving around with my top down on my expensive Mercedes, and I'm a little chilly, so I need to kind of warm this up a little bit. So we're going to go check out this air scarf system here. So let's see. I think it's in here. So that's different switches. Hold on. I picked the wrong article here. There we go. I think it's this one. It's going to give me description and function. Yes. So we have a control module for that. It's located behind the right rear seat in the partition wall to the trunk. Communicates over the heater LIN bus with the rear signal acquisition module. Depending on the request, the control actuates the following components directly: the left and right air scarf fan motors and the heating elements. So it is a fan that blows out of the top, the headrest, and it blows heated air around my neck to make sure that I am staying warm when I have my top down and I'm cruising around on a fall evening. All right, so here's my air scarf function right there. It's got the different modules there. Control unit actuates depending on the following variables. Select the heating level, outside temperature, vehicle speed, and soft top status. So it gives you a couple different 3 LEDs, 2 LEDs, 1 LED. So it's got 3 levels. And then you can turn it off. It's got the motors and the heating elements. Sends the outside temperature value over CAN, vehicle speed, soft tops. It's crazy stuff, right? So what do I need? It'll also shut off if it gets overheated. Switching by energy, battery management. So crazy stuff to think about it. So that's just looking in ShopKey. What does it do? How about let's go into the scanner and see what we do. Wow. So this was another thing I kind of thought about. Forget what part of the car it's on. Body control. Air scarf. There it is. Body control. Air scarf system. So codes, data, functional tests. What are my functional tests? I got special functions. What is the last cause of the automatic shutoff of that? I need to know that. Actuator tests. Takes approximately 5 seconds. So that's actually a actuator test that just goes through and actuates the different actuators in there. It goes through them for about 5 seconds to make sure they work. And then as far as data, what do I need? So I'm going to need there's function test data in here too. So status of the motors, whether or not I'm actually testing it. What is the amperage rating on those? So a lot of interesting information can be had. What's my outside temperature? What's the temperature of the control unit? What the blower stage is on the left and right. Current vehicle temperature. So if I'm chilly, I want to warm my neck up a little bit on one of those cold fall evenings. I can do that if I got a Mercedes. Kind of crazy. But hey, this is stuff we have to fix. If they fail, this is stuff we need to figure out how to fix. With that, that is my time for these driver comfort systems. That is a crazy comfort system. Let's talk about next week. So next week, we are continuing our component testing series, and we are focusing on diesel injectors, right? So diesel fuel injectors are similar to like gasoline direct injections, totally different than normal gasoline injectors. We have a couple different ways that they work, a couple different ways of firing them, because we do need diesel injectors are a lot higher pressure than what we're used to in the gasoline engine. So if you only work on gasoline engines, this would be a good place to come. So that's next week, next Tuesday, same time, same place, 6 and 9 Eastern. If you go to snapon.com/OT to register there on Zoom. You can also watch the 6 o'clock Eastern live on YouTube if you're more of a YouTube person. If you are watching on YouTube, please make sure you subscribe to the channel, give a thumbs up, make sure you like the video. Thank you for all the likes so far. And you can watch us on youtube.com/Snap-on Diagnostics. New material all the time. So we're actually up to 50 classes. So this is class 49, and then diesel injector class is class number 50. And they are all available on the YouTube channel. If you go to youtube.com/Snap-on Diagnostics, all readily available for you. There's a playlist for all the live training events that we've done. And there's more to come as we go further on in time. By the way, I don't have a slide for it, but on Thursday at 8 p.m. On the Zoom channel and also on the YouTube channel. It's probably easier on the YouTube channel because on Zoom, I don't have the link. But if we go to the YouTube channel, at 8 p.m. Eastern on Thursday, we will be talking about the new software that comes out on Monday. So there is the new software that comes out every spring and every fall. So there's a new software update. So we're going to talk all about that, talk about the differences, what you're going to see, different tests and functions that you will have. So that'll be on Thursday, as I said. So this Thursday, that would be the 29th at 8 p.m. Eastern time. So you just go to youtube.com/Snap-on Diagnostics, or if you're subscribed, you'll get a notification anytime we go live. See, so I'm going to start advertising that tomorrow because we're going to do it for 3 weeks. But that is definitely will be something to watch on Thursday. Let's take a look at questions. So looks like we don't have quiet night on Zoom today, and that's all right. How about on YouTube? So we got Quinn Hall saying hello. Good to see you. Abel, hi, good to see you there. Baja Joe, as always, glad to see you. Coming from San Antonio. And Quinn says, hey, San Antonio has a really nice city and river walk. I would agree. DF Repair, thank you very much. Robert Gomez, thank you very much for saying hi and checking and taking a little bit of time out of your day. Also note, let's talk about my buddy Al. So my buddy Al also does on-tool training, diagnostics training, specific to a scan tool. So on a Monday is Apollo, Wednesday is on Zeus, and Thursday is on Triton. They're at the same time as my classes, so 5 and 8 Central, 6 and 9 Eastern. They are live on the tool, and it's designed so you can kind of go there with your tool in front of you, follow along with everything he does. We're going to go through, let's make sure your Wi-Fi is set up on the tool first. Next thing we'll do is make sure you're set up on your free Snap-on Cloud account as well, because there's a lot of functionality involved with that you can do. Then he's going to walk through a real-world scenario, code to completion on the built-in vehicle, so you can actually follow along on your tool. Go through Fast Track Intelligent Diagnostics. How does it help me as a technician diagnose cars faster, easier, and all? So that's the Monday class, and then Wednesday and Thursday, that's the first hour. On Wednesday and Thursday, since those tools have scope and meter functions, he goes through another hour after a 5-minute break and goes through all the scope and meter functions on the tool as well. So definitely worth your time. 34 years with the company Al has been, and it's been all with diagnostics. So definitely a wealth of Snap-on diagnostics information. Go to snapon.com/OT to register for that. Save your seat. He does them only on Zoom, so it can kind of be a little more personalized. You can ask some questions, and he can give you your answers that you need. With that, looks like we are clear. So I'd like to thank you very much for taking a little bit of time out of your busy day, busy schedule, and spending a little bit of time with me. So hopefully we learned a little bit more about those weird, wild driver comfort systems that we may run into someday on one of those vehicles out there, because it's like heated seats is pretty standard nowadays on many vehicles. So with that, hope you enjoy the rest of your week. Hopefully we can see you next week for diesel injectors, and hopefully we'll see you Thursday for our software release as well. We're going to talk about that on Thursday, like I said. So enjoy the rest of your night. Enjoy the rest of your week, your weekend. See you next week. Have a good night. Take care.